In this video, we want to look at an example where we know the probability or the area beneath the normal curve, but we want to find the particular value of the variable that has the given probability. The reading speeds of 6th grade students is approximately normal with a speed of 125 words per minute and a standard deviation of 24 words per minute. What is the reading speed of a 6th grader whose reading speed is at the 90th percentile? A school psychologist wants to determine the reading rates for unusual students, both slow and fast. Determine the reading rates of the middle 95% of all 6th grade students. What are the cutoff points for unusual readers? So this is the same scenario that we've used in previous videos. We know that the reading speeds of 6th grade students are normally distributed with a mean of 125 words per minute and a standard deviation of 24 words per minute. We're looking for the 90th percentile. So what's the speed, the reading speed of a 6th grade student who's in the 90th percentile? And then we want to find the cutoffs for the middle 95% of 6th grade students. So let's take a look at this on a different sheet. So again, we know that the mean is 125 words per minute. We know that the standard deviation is 24 words per minute. And we know that we have a normal distribution. So the distribution is going to look like this. We have our variable reading speed. The mean is 125 words per minute. The standard deviation is 24 words per minute, so 125 plus 24 is 149. That's where this inflection point is. 125 minus 24 is 101. That's where this inflection point is. So this is our model that we're going to use. Now in part A, we're wanting to find the reading speed of a kid who is in the 90th percentile. So if the child is in the 90th percentile, here is the 125. That means there's a reading speed over here so that that value is at or higher than 90% of the other reading speeds. So this area right here is 90%. We want to find this value of x that has 90% of the other reading speeds to its left. So how do we do this? Well, we can do this a couple of different ways. One, we can begin by using our normal table to find the z-score that has 90% to the left, and then we can convert that z-score to our reading speed. So if I pull in our table, I know the area to the left needs to be 90% or 0.9000. So I want to find in the guts of the table the area of 0.9000 or the closest thing to it. So here we have 0.8997 and 9015. So 9000 is between those two values, but it's closer to the 8997. So that matches up with a z-score of 1.28. Okay? So if we were looking at the standard normal distribution instead of this distribution, the mean would be here. If this area is 90%, so this area is 90%, then this z-score would be 1.28. So likewise, this area is 0.90, and so we can go in reverse. We're going to take this z-score and change it into our raw value x. Okay? So we know that z equals x minus mu over sigma. And in this case, if the area to the left is 90%, means our z is 1.28, then z equals 1.28, and that's going to equal x minus 125 divided by 24. So if I solve this equation for x, then that will tell me what the reading speed is of the child who's in the 90th percentile. So if we multiply both sides by 24, 1.28 times 24 equals 30.72. So 30.72 is going to equal x minus 125. And if I add 125 to both sides, then x is going to equal 155.72. So if we round to the nearest word, that would be about 156 words per minute. So if a child is in the 90th percentile, that child reads 156 words per minute. Now let's look at part B, and let's look at it on a separate sheet. So in part B, we want to find the cutoffs for the middle 95%. So again, here is our normal model. 125 is here in the middle, and so we want to find two values. Here's one value, here's another value, so that the area in the middle is 95%. Okay, so in other words, that area is 0.9500. Okay, now if the area in the middle here is 0.9500, then that means the area out here in this tail and this tail total is going to be the other 0.0500. And so half of that's going to be in each tail. So if we divide that by 2, that's going to be 0.0250. So this area here in the tail is 0.0250. This area here in the tail is 0.0250. So again, I can use my normal table to figure out the corresponding z-scores. So looking in the table, this time I've gone to the negative side, and I am looking for 0.0250, or the closest thing that we have to it. So looking through the table, here we have 0.0250, and that matches up with negative 1.96. Okay, so our z-score that corresponds to this left value here, so that this area is 0.0250, is negative 1.96, which means this value over here, the z-score, is positive 1.96. Okay, so if we convert this z-score back to an x, that's going to give us this value. If we convert this z-score back to an x, that's going to give us this value. So again, we know z equals x minus mu over sigma. So negative 1.96 is our z. That's going to equal x minus 125, because that's the mean, divided by 24, because that's the sigma. Now, negative 1.96 times 24 is negative 47.04, and that's going to equal x minus 125. If we add 125 to both sides, then we get 77.96 equals x, so that is approximately 78 words per minute. So that would be this value here, about 78 words per minute. Likewise, 1.96 is going to equal x minus 125 divided by 24. If we multiply both sides by 24, that gives us 47.04 equals x minus 125. And if we add 125, that's going to be 172.04 equals x. So approximately 172 words per minute. That would be this value. So again, the psychologist wants to determine the reading rates for unusual students, both slow and fast. So any student that reads under 78 words per minute would be unusually slow. Any student that reads above 172 words per minute would be unusually fast. So our usual range would be 78 words per minute to 172 words per minute. Anything outside that range would be considered unusual. Now, we can also do these problems using the calculator and using StatCrunch. So I want to illustrate that as well. So I'm going to bring back in our first problem, okay? And we're going to use the inverse norm command on our calculator to do this problem next, okay? So remember, with the inverse norm command, we put in the area to the left, comma, then we put in the mean and we put in the standard deviation. Well, before we used 0 for the mean and 1 for the standard deviation because we were dealing with the standard normal. But in this case, we can use our mean, 125, and our standard deviation, 24, and the calculator will do the work for us. So, for example, in this case, we're going to do inverse norm. Our area to the left for part A was 0.90 because we're at the 90th percentile. Our mean was 125 and our standard deviation was 24. So if I pull in my calculator, go to second and distribution and inverse norm, the area to the left is 0.90, our mean is 125, our standard deviation is 24, and I do have the area to the left. Now remember, in my new calculator, I have this option of choosing left, center, or right. If you have an older calculator, you don't have that option. It has to be the area to the left. And so I get our result, 155.76. So this gives me 155.76, which is about 156 words per minute, which agrees with the result we obtained before. Now notice that it was off in the hundredths place, but that was because we had to round. We didn't get exactly 0.90 when we used the table, and so that's the reason for the discrepancies, the rounding. Now, looking at part B, I can do the same sort of result. So if I'm going to use the inverse norm on my calculator, well, to find this value here, I can do inverse norm. My area to the left is 0.025, and my mean is 125, and my standard deviation is 24. So if I go to distribution, inverse norm, change this 0.90 to 0.025, my mean is 125, my standard deviation is 24, and the area of 0.025 is in the left tail. So I paste, and so that is 77.96. So 77.96, which is approximately 78 words per minute as we found by hand. So that is this value. If I want to find this value, now if I have an older calculator, then I have to determine the area to the left of this value. Well, if the area to the right of this value is 0.025, then the total area to the left is 0.975. Okay? So I could do distribution, inverse norm. So if I enter 0.975, again, it's the area to the left, I get 172.04. So I have inverse norm of 0.975 with a mean of 125 and a standard deviation of 24, and that was 172.04, so about 172 words per minute. Okay? Now again, this is how it would be on an older calculator without the option of left, right, or center options. Now on this newer calculator, if you have a newer calculator, you do have the option of leaving this at 0.025 and instead changing to right, so that we're telling the calculator the area in the right tail is 0.025 with a mean of 125 and a standard deviation of 24, and I get the same result. So I also have the option of doing distribution, inverse normal, and typing in the area 0.95 in the center and pasting, and that gives me both values, the 77.96 and the 172.04. So I have that option to find both at once. Now let's look at how it would appear in StatCrunch. So in StatCrunch, we can go to Stat and Calculators and Normal. If I'm looking for the 90th percentile, first of all, I know the mean is 125 and I know the standard deviation is 24, and I have the left area of 0.90, so I have it as less than, and I'm going to enter 0.90 in this box and say compute, and that gives me the value here, which is 155.76 rounded to two places, or 156 words per minute, as we got both with the calculator and by hand. For the second part, doing the 95%, we can do it the same way that we did on the calculator. One, we figured out that the area in the left tail is 0.025, so I could use that and type 0.025, and that would give me the 77.96 or 78 words per minute. I could also then use the 0.975 to get the 172.04. Or I could have changed this to greater than and typed in 0.025, and that would give me that result. Or I could go to the between option and I could type in 0.95, the area in the middle, and it would give me both values. So we can either do this by hand using the normal table, we can use the inverse norm command on the calculator, or we can use the normal calculator in StatCrunch. Any one of those options will allow us to figure out problems such as this.